Hey everybody, today's lesson is going to be about arithmetic sequences. Some people may pronounce that arithmetic sequences. I say arithmetic sequences. I don't know if I'm doing it right or wrong, but nonetheless, it's one that is not too bad, and once you get the hang of it, this one's actually going to be hopefully a lesson that you feel like is pretty manageable. So the big idea is for an arithmetic sequence, they will give you a sequence of numbers, right? A sequence is just a list. The little ... is called an ellipsis. That just means the pattern continues to infinity and beyond, right? And so the thing with arithmetic sequences, they have to be a sequence that has a common difference, right? And when I say common difference, that means the pattern that you notice is going to be adding or subtracting, but honestly, you can think of it either way. It's not going to be a multiplying pattern, right? You're not going to see a list where the numbers are being multiplied by a certain amount every time. Like if you look here, my red one, 5, 10, 15, 20, right? It doesn't take a Rhodes Scholar to see that here the common difference is positive 5 because we're adding 5 every time. Down here on my blue one, the numbers are getting smaller, going down by 7 every time. Some people would say that's subtracting 7, right? Some people would say, okay, you're doing minus 7, minus 7, minus 7. If I'm being really honest with you, our book will say that it's adding negative 7, right? Adding negative 7, adding negative 7, which is the same thing as subtracting 7, so don't let that throw you off. What you will not see, and I just mentioned this a minute ago, you will not see a pattern like this, right? Where it goes, I don't know, and of course I pick one that's really hard. Right, something like this. I messed that up. 108. Right, you wouldn't see something like this. Holy cow, I'm having a brain meltdown. I'm just gonna have to do it over here. It was 108. I'm sorry. You wouldn't see something like this as an arithmetic sequence, right? Where it's multiplying by 6, multiplying by 6, right? Multiplying. This is not an arithmetic sequence. That's actually something different, which we'll learn later, called a geometric sequence. So today, it's not going to be multiplying or dividing. Every single pattern will be adding or subtracting. And really on the subtracting ones, you can just reference that as adding a negative. So it's going to be adding or subtracting only, and that is it. The first type of questions today, they're going to ask you to continue the pattern, right? They're going to give you the arithmetic sequence. They're going to say, find the next 3 terms. Now, the word term here just means the next 3 numbers in the list, right? Like if I just had each number here is a term, right? It's almost like the word term almost means like position, right? Negative 12 is the first term. It's in the first position because it was the first number in the list. 0 is the second term. This is the third term. This is the fourth term. And so when you see the word term, that just means the order that it is in the line, right? The order that it is in the list. So if this question asks me to find the next 3 terms, I need to find the next 3 numbers in this pattern. You've done questions like this throughout elementary school and even like 5th and 6th grade. Here you just got to see what the pattern is, right? It's adding 12, adding 12, adding 12. It better be doing the same thing every time. If you're not adding the same amount every time, you've either made a mistake or you don't have an arithmetic sequence. You have something else which is not going to be appropriate for today's lesson. So you can see there, adding 12, I just put the next 3 numbers on there. In this scenario, on number 2, I've got the next 3 numbers I need to fill in. I'm going to look for the pattern. These are decimals, but I'm not going to let that throw me off. This is obviously getting bigger, so it's going to be adding a positive, is that 0.4? 0.4? 0.4? I believe it is. So if I add 0.4 again, 1.4 plus 0.4 is 1.8, and then 2.2, and then 2.6, right? A lot of these patterns you can do in your head completely, and that's what makes them kind of nice. Don't really need a calculator for a lot of them, although you might. Here's one with fractions and mixed numbers. Don't let that throw you off. The numbers are getting smaller. Now, this is subtracting 1/4, isn't it? They're going down by 1/4 because 1/2 is the same thing as 2/4. It's going down by 1/4, and so if I needed the next 3 numbers, I'm just going to keep subtracting 1/4, or remember the book could call it adding negative 1/4, but let's be honest, that just doesn't make as much sense to think of it that way when you're just doing mental math. So I'm going to say the next number would be 3, and then 2 3/4, and then 2 2/4, which actually 2/4 is obviously 1/2. So you're going to get some questions today that ask you to continue the pattern. Tell me the next 3 terms. Just find the pattern. It should be doing the same thing from one term to the next, and just continue it. Super easy. Okay, if they ask you to graph some, don't have an issue with that. It's kind of weird, like, to graph these, because you're going to feel like, wait a second, I don't even have like a second set of numbers, right? How do I graph these if I don't actually have everything I need? I'm gonna, just give me 1 second here. 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11, that's 11, that's 4. I'm looking here, that's the biggest number. Oh, actually we have a 12. Should actually go to 12. I'll go up one more spot. So if they only give you a pattern like this and they say, hey, graph this. Okay, don't have a panic attack. It's not really that bad. So this is the first number, right? The first number is 3. So what that means is you're going to have the point 1, 3 to represent the first number being 3. And then the second number here, right? The second term is 6. So you're going to have the number 2, 6. So you're going to go 2 to the right and then up 6. And what you'll notice about these, here's your third term, right? 9 is third in the list, so you'll have 3 with 9. And then the fourth number in the list is 12, so you'll have 4 with 12, right? So the x-coordinate is actually what term it is, right? The first term was 3, so I did 1, 3. The second term was 6, so this is 2, 6. And so then I would have 3 with 9, and then I would have 4 with 12. And if you do this well, now my graph, I just freehanded it, but if you do this correctly, it should make a perfectly straight line, right? It should be perfectly linear. The common difference is actually the slope, and so this should be going up 3 over 1, up 3 over 1, up 3 over 1. It should have a consistent rate of change, a constant slope. Number 5, I'll just put it on the same graph. The first term right here is 4, so I'm going to graph the point 1 because it was the first term, and then 4. The second one is 2. So the second term, that's what that represents, was 2. The third term right here is 0. So the third term, number 3, because it was third, is 0. And then the fourth term is -2. So my fourth term is -2. I'm just going to graph those 4 points on the coordinate plane with you guys being able to do the assignment on the computer. Whoops, 1 and +4, not -4. 3, 4. 2 with 2, 3 with 0, 4 with -2. The cool thing about you doing these on the computer is you won't have to draw the graphs like this, and your line should be perfectly straight because it's going to be done electronically on the computer. And then the fourth, this other one here, right? The first number is 2, so I'm going to put a 1. For this one, the second number, number 2, means the second number, the second term. Here, the third term is 7, and here the fourth term is 11. So 1 goes with 2, 2, 4, 1, 2, 3, 4, 3, 7, 1, 2, 3, 4, 5, 6, 7. 4 goes with 11, and so that one is kind of steep as well. But you can see how graphing those, they should make a straight line. They should have a constant rate of change, a constant slope. And if for whatever reason they ever give you a sequence, like they're going to give you some graphs and they're going to ask you, is this an arithmetic sequence? Just check and see. Is it going up by the same amount every time, right? Is there a constant rate of change? Like here, adding, whoa, actually I just screwed this one up. This one was an arithmetic sequence. I just now noticed, right? This one was because it's going -2, -2, -2, so this is good. This one is adding 3, so it's good. I wondered why this one kind of had a curve, a bend in it right there. Look at this. This is adding 2, and then it's adding 3, and then it's adding 4. And so this actually, you can see it kind of has a little bend in it right there. That is not an arithmetic sequence because it didn't have a common difference, right? It didn't have a constant rate of change. And so it's going to give you a graph and it's going to ask you, is this an example of an arithmetic sequence? Just make sure you check to see if the line's kind of curved, then definitely no. And when you do it on the computer, it'll be a lot easier to tell if it's curved than mine, where I kind of freehanded it, and it's not always easy to tell. You can also just look right here and see if the pattern is the same, right? Okay, whoa, kind of knocked some of my red marker off of here. This is the hardest part, and it's not really even that hard, but this is the part that is going to take a little bit of equation work. They're going to give you a sequence, and they're going to ask you to write it as a function, right? Write it as a function. And so what we have today is a new formula you've never used before. And don't let this bother you. It's actually very easy once you get the hang of it. It looks a little bit strange because you've never seen this before, most likely. But don't let it cause you any stress. It's not that bad. This will probably be what they ask you, like on a test. If I had to make a guess, what type of question would they ask you? It would be something like this. Really, the questions we did before, those are almost too easy. So they're going to give you a function, an arithmetic sequence, and they're going to ask you to write it up here like a function. Okay, let me kind of just go over what these things are. This A with an N underneath it just means any number. So if I'm looking for any number in this pattern, right? Because right now I can see the first four numbers, 4, 5, 6, and 7. What if I said, hey guys, what's the 20th number in this pattern? What's the 80th number in this pattern? What's the 500th number in this pattern? Right? Whatever number they ask. I'm sorry, guys. Whatever number they ask for goes in this spot. A1 is always the first term, the first number in the list. So like on this example, the A1 is going to be 4. On this example, the A1 is going to be 8. This number and this number is the same. So if I'm looking for the 20th number, we're going to put a 20 right here. If I'm looking for the 18th number, I'm going to put an 18 right here in both places. So this is just whatever number, the number you're looking for. And then D represents the common difference, right? What the pattern is, the common difference. Let me actually get rid of my smiley face and my arrow. The common difference. So they actually told you all of that here with number 7. It's not really that bad. You just got to kind of get the hang of doing it. So what do I need to know? I'm going to do my equation here for number 7. A with an N, because they didn't say, hey guys, find the 20th number. I'll do that in a minute. A with any, if I'm looking for any number in this list, I'm going to have a equal sign, and then I'm going to do A1. A1 is the first number in the pattern. The first term on this one is a 4. Plus N minus 1 is always there. And then you're going to multiply it by the common difference. Common difference is, what's the pattern? What are these numbers counting by? What's the consistent change from one term to the next? They're obviously adding 1, positive 1, right? Because they're adding. So I'm going to put a 1 right there. The common difference was 1. Now, sometimes they will leave the answer like this. In multiple choice questions, you might be able to like circle this and say this is your answer. Every once in a while, which I think our book is actually going to make us multiply it out, right? Our book is going to make us distribute. Now, distributing here is kind of backwards because the 1 is at the end. Usually the 1 is in front of the parentheses. But they're going to make us like distribute, right? 1 times N, 1 times minus 1. And then they're going to make us combine like terms, right? They're going to make us say, oh, wait, now you've got this 4 and you've got this minus 1. So you can do 4 minus 1, which is 3. And you can write your answer as 1n plus 3, right? See how I put the n at the beginning, and then here I just did 4 minus 1, and I got 3. That's probably what they'll have us do on today's questions on the website. So it's nice when you get to keep it like this, but also don't be afraid to actually distribute and then combine like terms and write it like this, because these are the same thing, but they just write it 2 different ways. So let me do one more of those, and then I'll show you kind of how this is useful. Like, what's the whole point? Why would you even write something like that, right? Let's do the next one. 8, 16, 24, 32. So I'm getting ready to write my formula. I'm following the path up here to find any number in this pattern. I'm going to do, it's going to equal A1, the first number. The first number is 8, plus, and then n minus 1 is always there, times the common difference. What are these numbers going by? These numbers are getting bigger by 8, so my common difference is 8. If these would have been going down, like I would have put negative 8, and this would have been a negative 8. Okay, now, in an ideal world, this would be my answer, and I would circle it, and I would be done. In multiple choice, if this is one of the choices, I would definitely go for it. But if that's not one of your choices, you're going to have to actually distribute this thing, right? 8 times n, 8n. 8 times minus 1 is minus 8. And then just kind of drop down this plus sign, drop down this 8, drop down the equal sign with the a sub n. And now you've got some like combining of like terms to do, right? This and this are just regular numbers. We can combine those together. And this one's a little bit weird because 8 minus 8 is 0. And so my final answer is just going to be like this and this are going to cancel each other out. You're just going to have 8n. And so that would be my equation. Okay. Now, what's the whole point of this, right? What's the whole point of doing something like this? What if I ask you guys, what's the 70th number in this pattern? Are you going to like count on your fingers 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, until you have 70 numbers, right? Or make a list on a paper until you have all 70 numbers written down? I mean, you could do that, but that's going to take forever. The faster way to do it is to just put, if I want the 70th number, let's just say on this one down here, right? Let's say I ask you, what's the 70th number? You would say, okay, if I need to find the 70th number, look, I'm going to put a 70 in the spot of the n, right? See how you can just plug it in? If I want the 70th number, I'm just going to do 8 times 70. And that is something you can either do in your head or with a calculator. And you could say, okay, A with a little 70 underneath it, A sub 70, the 70th number in this pattern is 560, right? And if I didn't want the 70th number, maybe the book just says, hey, what's the 18th number? Okay, well, instead of 70, I'm just going to put an 18 right there and say 8 times 18, right? And then I could work that out. On this one up here, if I wanted the 70th number, I could say, okay, what's the 70th number? I could do 1 times 70 plus 3. Or to be honest, you could have put 70 right here, right? You could have put 70 in this place. You could have done 70 minus 1, that's 69. 69 times 1 plus 4, right? That's the same thing. Or if I wanted the 18th number, instead of putting it in here, I could have put 18 right here and done 18 minus 1, which is 17. 17 times 8, and then add 8 to that, and you would have had it as well. Okay, last ones. What happens if they give it to you as a table? Is that really going to matter? No, you're going to do the same thing, right? Don't let that throw you off. Remember, here is your formula. Here's your setup. Okay, I'm going to write it like this. There it is. Okay, if I say, what's this as a function? Just write it as a function. Remember, here is your pattern, how much money people have bid on something. So I'm going to do A sub n equals A1. A1 is the first number in the list, right? That's what this is. Number 1, right, is 60. And then n minus 1 times D. D is the common difference. What are these counting by? Boom, boom, boom. That's obviously counting by 5. Perfect. And this could be your answer, right? And then if I ask you, hey guys, what would it cost if I had made 20 bids instead of stopping at 4? What happened if I would have gone all the way to 20? Well, there's 2 ways to do it. Step 1, if I want the 20th bid, you could put 20 right here and right here, right? If you wanted to, you could do this, put 20 in the place of n, and then you could work this out, right? 20 minus 1 is 19. 19 times 5 plus 60. Got to do the multiplying first. 19 times 5 is 95. 95 plus 60 is 155, right? So the answer should be A with a 20 underneath it. The 20th bid is $155. Or what our book is going to make you do, our book is going to make you like distribute this thing, right? Our book is going to make you do 5 times n, which I'm just going to put it down here, and 5 times minus 1, or negative 1, which is negative 5. And they're going to make you copy down all this at the beginning, right? AN, and then 60, and then the plus sign. And then our book's going to want you to like combine this term and get 55, right? 60 minus 5 is 55. So our book is going to want you to say this, right? A with an n underneath it equals 5n plus 55. It's the same thing as this, right? If I put 20 in this formula, I'll get the same answer, right? If I put a 20 right here, I'll do 5 times 20, which is 100, right? 100 plus 55, and 100 plus 55 is the same thing, right? Still 155. That's what I got right there too. So I get the same thing. It's just a different way to do it. Okay, I'm going to do one more and then I need to stop because this video is going to be 20 minutes. And I apologize to make you watch a 20-minute video. Same thing over here on number 10. If they give you a table that's vertically kind of aligned in format, don't let that throw you off as well. Remember, here's your formula. I shouldn't have erased it, but I had so much writing up there. I thought I would going to just overwhelm you with scribbles. So here's your formula. All you need to do to fill in this formula is you need to know what A1 is, the first number. The first number is always going to be right here, right, the 7. When you've played one game at like this carnival or this fair, you've paid $7. $7, and then n minus 1 times the common difference. The difference is what's the pattern going down? How much does each game cost, right? What's the rate of change? And in this case, each game costs another $2, right? 7, 9, 11, 13. So each game costs $2. And so in a lot of tests, this would be your answer. And then they might, well, in our case, the book's going to make you actually distribute this and actually simplify it. They're going to make you do 2 times n. They're going to make you do 2 minus 1, or 2 times negative 1, excuse me. And then our book's just going to make you copy all this down And then last but not least, they're going to want you to like clean this up a little bit, right? Combine these like terms. 7 minus 2 is 5. Actually, I want to put this first because the n usually goes first. The variable usually is at the beginning. 7 minus 2 is 5, positive 5, so I put a plus. So you have two versions of the same thing. These are the exact same formula, just written two different ways. And so the whole point of this would be, hey guys, what happened if I spent the whole day at the carnival and I, let's say I played 100 games, right? Instead of 4 games, I went all out and I played 100 games. How much money would it cost? I don't want to make this pattern do 100 numbers. That's going to take forever. I can just put 100 in the spot of n in this formula. I could do 2 times 100 to represent I'm playing 100 games, and that would be 200 plus 5, right? And so if I played 100 games, I would have to pay $205, a lot of money. Or you could have put 100 up here. Let me kind of erase this. I could have put 100 here and here into the other formula, right? And had a with 100 and do 7 plus 100 minus 1 times 2, right? 100 minus 1, parentheses first, is 99. I'm going to go ahead and give myself some room. 99 times 2 plus 7. You got to do the multiplying first. 99 times 2 is 198. 198 plus 7 is going to give me my answer for a sub 100, and 198 plus 7 is 205. So you see I got the same answer both ways. Okay, that is this entire lesson. I am going to stop because I've talked for too long, so sorry this went over 20 minutes. But hopefully this is going to help you. I'm going to put some questions on the Big Ideas Math site. Hopefully you can do well. If you're struggling or something just isn't jiving with you, you're having some issues, feel free to email me and I will do my best to get back with you ASAP. All right, have a good one out there.